Okay, so real quick, I just want to do a video to review significant figures because it's been a while. So significant figures are basically, it's just a way of recording values, and it all goes back to measurements. It all ties into measurements and how precise those measurements are. So for example, if I gave you a beaker and it was marked to the 10 milliliter spot, and if I gave you a graduated cylinder and it had markings like every 1 milliliter, right? Which one would you rather use if I said to measure 1 milliliter? Well, you would probably choose the graduated cylinder because it actually has markings, right? You could guess about 1 milliliter might be somewhere in there, right? So if I told you to write down your measurement, you would probably write 1 because you're guessing, right? You're guessing that it's 1. If you measured using your graduated cylinder, you could estimate all the way to the tenths. Because if you were right on the line for a milliliter, you could say, well, it's 1.0 because I'm right on the line. I know it's 0.0. So basically what we're saying then is that this instrument is more precise, okay, because it has measurement values at more like place values. My measurement is more descriptive or more precise, more on the nose, you could say. Okay, I have fewer levels of uncertainty, right? Whereas my 1 milliliter, I'm not even certain about the 1. I am not certain about that measurement at all. With a graduated cylinder, I'm very certain that it's at least, I know the 1 is right because I can see the marking. The 0, I think I'm pretty sure, but it's still just a guess, right? Because I don't actually have a marking for that. Maybe you said it was 1.1. Who knows? Maybe you're a little bit over it and you guessed 1.1. Okay, you're still sure about that first 1. So that's basically what we're talking about when we're talking about significant figures is we have these meaningful values that all tie back to how precise our measurement is, okay, and how much uncertainty there is. So the fewer significant numbers in my measurement, the more uncertain I am about that value. Okay, so we have some rules. All non-zero numbers are always significant. So 1 through 9. All zeros in between numbers are significant. So like 2009, this would have 4 significant figures because both the zeros are between numbers. And then zeros to the right or zeros to the left. Okay, it starts getting a little bit confusing with those rules. So the best way to remember it is this Pacific Atlantic kind of idea. Okay, so if I imagine my number is sitting on top of the United States, I know my Pacific Ocean is over here, and I know my Atlantic Ocean is over here. If my decimal is present with a P, then I'm going to start looking at my number from the Pacific side, so the left side of my number. So if I look at this first example, 0.01020, I'm going to start counting from the Pacific side because my decimal is present. I'm not going to start counting until I get to an actual number. So now I can count 1, 2, 3, 4. There's 4 significant figures. Notice I counted all the way to the end of the number. I didn't stop at the 2 because there's a 0 at the end, right? The whole point is to count those zeros. If I look at the last number, 300.03, again, I have a decimal. It's present. I'm starting from the Pacific. Here, I start counting at the 3 because I immediately run into a number 1 through 9. Once I start counting, I don't stop. 1, 2, 3, 4, 5. So this has 5 significant figures. If I look at the number in the middle, I have no decimal, 56,000. My decimal is absent. So I'm looking at the Atlantic side. I'm starting to count. Again, I'm not going to start counting until I get to a number. Once I get to that 6, I can start counting. So there's 2 significant figures. Okay, so let's do a couple practice. Number 1, easy. No zeros to even think about. Numbers 1 through 9, therefore I have 2. Number 2, same thing. All those numbers are actual numbers, so they're all significant. Okay, number 3, I do have a 0, but it's in between my significant numbers, 1 through 9, so it counts. So that has 4. Okay, now I'm getting into, okay, I have a decimal, and I have all these zeros, and I'm not really sure if I'm supposed to count them or not, right? Because they're before. Decimals present, I'm starting up from the Pacific. I'm not going to count until I reach a number. 3 and 5, so there's 2. Number 5 is very similar to number 3. There's a 0, it's in between other significant numbers, so I have 4. Number 6, I have a decimal point. It is present, so I'm starting from the Pacific Ocean over here. Moving this way, I can't start counting until I get to an actual number. Once I hit that 4, I'm going to start counting, so there's just 1. Number 7, again, Pacific, present decimal. I start counting as soon as I get to the 2. 1, 2, 3, 4, 5. Notice how I kept counting again all the way to the end. Once I start counting, I don't stop until I reach the end of the number. Again, number 8, I have a decimal, Pacific. Starting from that side, I start counting as soon as I get to a number. 1, 2, 3, 4, 5, 6, 7. 7 significant figures. And I realize I don't have any from Atlantic, so let's write 1 or 2. Okay, change colors. So number 9, no decimal. Decimal's absent, so I'm starting from the Atlantic. Right, Atlantic's over here, Pacific's over here. I don't start counting until I get to an actual number, so I'm skipping all those zeros. 3. Same thing over here. I don't start counting until I get to a number. 1, 2, 3. Notice how I counted that 0, because remember, once I start counting, I keep going. Same thing, no decimal, it's absent. I'm starting from the left. I don't start counting until I get to a number. There's just 2. Okay. The last thing that's important, especially for when we're doing all these mul calculations, is talking about what are our rules when we're multiplying and dividing. Okay, so our answer is always going to contain the least number of sig figs. So when I'm looking at my calculation, whatever numbers I'm given in the problem, not what I look up off the periodic table, but the number that I'm given, whichever is the least, that is the number that I'm using. So here I have 2, here I have 3 sig figs. So when I type that in my calculator, I want to make sure that my answer is only going to have the least, 2. Okay, so I get lucky with this one. It's just 8.8. I don't even have to do any rounding. This has 2 sig figs. Okay, when I'm looking at something written in scientific notation, I'm just concerned about these first parts. I'm not really worried about counting anything with my times 10. Okay, so if I'm just looking at the beginning of the number, I have 3. Oh, here I have a decimal and I have this 0 at the end. I'm not really sure what to do, but I know that when a decimal is present, I'm starting at Pacific, which is this side. So I start counting here. 1, 2, 3, 4. 1, 2, 3, 4. Okay, count all the way across. So that means my answer can only have 3. So 4.52 times 10 to the minus 4 divided by 3.980 times 10 to the minus 6. I get, let me write it over here. I get 113.5678. Right, I could keep going, but my answer can only have 3, which means I need to stop my answer right here. But since there's a 5 after this, that's going to round up my 3. So my answer is 114. Okay, so hopefully that gives you just a little quick refresher on significant figures, you are going to have to be able to put your answers from mole calculations and significant figures on your quiz. So make sure you've got a little bit of an idea about that. Okay, and let me know if you have any questions.